Uh,
Okay, 1 minute. Yeah, is it okay?
yes.
So, can I start now?
Yes, sure.
Yeah. Good morning to everyone. Good morning, Professor Akshep. Good morning, Professor Vijay. So, somebody just asked the question, what background is required? So, I'll answer that. Fortunately for my lecture, zero background is required for any information. Okay? Yeah. I'll just start. This is, we are going to talk about genetic algorithms. So when you hear the term genetic, the very first name comes to your mind is Charles Robert Darwin, Darwin's principle, 1809, 1882. So, and his principle is survival of the fittest. Though there are some views that Darwin may not be completely right. For example, the question comes why we see monkeys when human beings are around. Okay, so there is a debate going on for quite a lot. Doesn't matter. But by and large, we agree that survival of the fittest is valid. Okay. Now, you see that there are generations. The you can see that the human being has evolved over sort of thousands of years or millions of years, and this is the evolution. Now, I would take this opportunity to tell you that we all are also evolving as far as the online teaching is concerned, right? So don't expect too much. You can expect the very sort of primitive things as far as the online teaching is concerned, because we are all evolving, right? So keep your expectations slightly low. Now, the genetic algorithm, as told you about Darwin, everybody knows. Now I'll tell you one joke about a gentleman philosopher and an actress. You will wonder why I'm telling you this joke. This is at the heart of the genetic algorithm. The essence of the joke is at the heart of the genetic algorithm. Now, there is a gentleman philosopher and an actress. The gentleman philosopher is extremely intelligent but has ordinary looks. The actress is stunningly beautiful, having ordinary intelligence, right? Now, the conversation goes something like this. Actress to the philosopher, imagine a child with my beauty and your brains. Philosopher replies, yes, but imagine a child with my beauty and your brains, right? So both are expecting their children to be of completely sort of different categories, right? Philosopher can imagine that the beauty, I'll repeat this sentence, yes, but imagine a child with my beauty and your brains. That is the philosopher. And actress says, imagine a child with my beauty and your brains. They are diametrically opposite to each other. Now, just remember this joke, right? It seems to be a joke, but it conveys you the essence of genetic algorithms. Now, what are the advantages of genetic algorithm? One is robustness. Now, what do you mean by robustness? Now, imagine you have two metal strips to be joined together. You can use Fevicol to join them. Let us assume that it is possible. Or you can ask a welder to join them. Now, you will agree with me that joining them using Fevicol is a process which can be called as robust. Means anybody can do that with sort of not too specialized knowledge. But welding cannot be undertaken by anybody. It requires specialized knowledge. So the advantage of genetic algorithms is that they are robust. In the sense, even if, for example, there are certain concepts are involved in the genetic algorithm. For example, crossover, what is the probability of crossover? Everybody can have different opinions depending on the individual perception, right? So the point is that the genetic algorithms are robust. Then they can give very good solution in extremely challenging situation. Now imagine you have to do some minimization or maximization, and the situation is extremely challenging, right? So then cannot formulate a problem using calculus. There are many situations like this. For example, I'll give you one example of a problem. Let us assume that you want to uh, have a mathematical model of India, including the heights of the at different places. It will be sorry. It will be extremely difficult to have a mathematical model which will represent the height involved at each and every point of India. So to find out the maximum point of highest height will be extremely difficult, not only extremely difficult, impossible. So in such situations, what we do, we give up as far as the mathematical approach is concerned. So then we go to the algorithms like genetic algorithms, simulated annealing, particle form optimization to give us something. Okay. So now I'll just tell you one thing, what you can expect from genetic algorithms. You should not expect exact answers from genetic algorithms. In case you want exact answer, you should go to mathematical methods which are based on calculus. So, but as I said, there are some situations you are helpless. You cannot even model in mathematical solutions. So you go after the genetic algorithms or similar class of algorithms. Now, just to give you some idea, suppose there are 100 persons, they all spread all over world, they want to come to you. Let us assume, hypothetical situation, there are some 100 persons and they are scattered all over the world and they want to locate you. Of course, you have certain properties, they know you that they do not know your location, but they have approximate ideas, right? So assume that some of them come to India, not all of them, some of them will come to India, some of them will come to the state where you are. So you imagine a player in a kabaddi game, the player is always on lookout, who is trying to catch him, etc. So he is always on lookout for different directions. So some of the persons will come to your state, they will come to your sort of town also, they will come to your locality, they will enter into your building also. But even if though they come to your building and to your room, they will start searching. See, in other words, the genetic algorithms will give you as accurate result as possible, but unlikely that it will give you the absolutely correct answer. Okay, I'll just wait at this point. Did I make my point clear? I would expect any questions. If it is clear, at least one of you should say yes.
Yes, sir.
Okay.
Yeah, I think someone said yes. Please be interactive. Participants, please be interactive.
Yeah, be fast actually, because As I said, we are evolving. I am also evolving how to give online lectures, and I think you are also evolving how to sort of take part in the online lecture. Okay, fine. So let me now give you history. History of genetic algorithm is very interesting. The John Holland in the University of Michigan in 1960 came out with his genetic algorithm. He wrote a book, and when he wrote a book, he thought that he is writing a very popular book which will sell like anything. Okay, but to his dismay, even the first edition could not be sold out. The reason was it was highly mathematical. So anybody will sort of look at his book will say yes. In case there is an optimization problem, I should use the method of John Holland. But what can I do? It is too tough. It is too mathematical because he used extremely difficult mathematical language to convey how to go about optimization. The result was that his method was not understood by, I should say, many people, or in general, it was not understood. Then what happened? Uh, Gold, David Goldberg was doing a PhD in the same university, and he was working on the problem of optimization of pipe networks. Pipe, in the sense, you can imagine that, let us assume that there is a water supply to be given to a city. So the pipeline needs to be designed. What are the things that uh, the water supply should reach at each and every end? Then the power required for pumping, etc., should be minimum. So the design involves the diameter of the pipes, junctions, and so many other things. There would be losses if there are bends, etc. So all these things have to be considered. So you will agree with me that the designing of a pipeline network is an extremely challenging work. Okay, so he came across John Holland, and he decided, okay, he will try to apply his method, and he succeeded. Then what David Goldberg did, he wrote a book on genetic algorithms, which is the reason for popularity of genetic algorithms, right? So it became popular in, say, 90s. Now, the main purpose of the genetic algorithm is to solve problems where deterministic algorithms are too costly. Traveling salesman problem or knapsack problem are the description. In the industry, genetic algorithms are used when traditional ways are not efficient enough. Now, I just talked about trying to fit some mathematical curve to such a terrain. You will agree with me, it is extremely tough, right? Now, I just to take care of this problem, I'll just talk about how to deal with it in a real life situation. You imagine that you are having a satellite and it can direct the at random at maybe say 100 points and can get the readings of those points, right? So by doing these readings and by using the genetic algorithms, one can find out which is the maximum peak or which is the minimum peak almost approximately. Kindly remember, it will never be able to get you the absolutely correct thing, but very nearby to it, right? I'll just try to explain what exactly is meant by very nearby to our satisfaction. Suppose you are thirsty. You want a glass of water. Somebody is there in front of you. He has a jug of water which he can put in your glass. But he has one condition. He tells you that I'll fill your glass half. After that, if you want, I'll give half of half, that means 1/4. If you still want water, I'll give 1/2 of 1/4, that is 1/8. If you still want water, I'll give you 1/16. After that, if you still want, I'll give you 1/32. Now, please tell me, would you wait till he sort of able to fill the glass almost up to the brim? But please remember, he will not be able to fill the glass completely till he tries even infinite times. You agree with me? So there will be a situation where you will say, maybe after he will fill it half, then again half of half, half of half. It will be almost sort of glass full. As far as you are concerned, you will say, please stop it, right? So this is the concept of glass full of water as far as the real life, day-to-day life is concerned. Okay, so you can expect the answer to your satisfaction till you sort of get satisfied. So where to stop depends on you. Okay. At this juncture, again, I would like to wait. Am I making clear myself?
Yes, sir. Yeah.
Okay, fine. Now, after taking this extremely complicated thing, let us talk about some mathematical functions. So, unimodal function. Now, please remember, most of the optimization problems are concerned with either minimization or maximization, right? Now, you should not worry if somebody talks about maximization or somebody talks about minimization. They are, really speaking, same language. I'll put it this way. For example, negative of maximization is minimization, or negative of minimization is maximization. So you can use extremization. So depending on your interest, whether you would like to maximize or minimize, actually as per the mathematical method is concerned, it is the same. Okay. So please don't worry about somebody talking about maximization, somebody talking about minimization. You should understand them. Maximization is negative of minimization, and negative of minimization is maximization. Okay, vice versa. So this is a unimodal function. But it means that it has only one, in this case, let us say minima. Okay, I'll concern myself with the minima. So here it has only one minima. This is called unimodal function. Now this is also unimodal function, but very tricky. In the sense, you see that there is almost a flat portion at the top, and at some place there is some hole-like thing, and it has minimum here, right? So this is another example of unimodal function. Now this is multimodal function. As I said, I'll be concerning myself only with minimization. You can see here that there are, at many places, minimizations are there. Okay. This is multimodal function. Now this is another multimodal function, right? There are many, there are many places what we can call as local minimum. For example, here, are you able to see my pointer here? Because,
Yes, sir.
Yes, sir.
yeah, so these are the local minimums, and there will be some global minimums. There may be more than one also. So these are multimodal functions, and these are quite tricky. Tricky because there is a danger that your algorithm may get trapped in local minimum. Okay, so as you become expert in genetic algorithms, or for that matter, simulated annealing or other types of nature-based algorithm, you should always be wary that are you getting caught in the local minimum. So this problem needs to be addressed once you get acquainted with these methods. So you should always question yourself, you are getting answer, is it local minimum, right? So this question should be there with you all the time, all the while. And whatever necessary checks are required, you should implement them. The checks are, you run the another type of algorithm using different parameters, and try to get similar answer. Okay. So this, whether you are getting the correct answer or not, this is, nobody can give you guarantee. Okay. But be sure that you will be able to sort of find work solution for this. Now, some GA application types. And this is just to give you idea that the knowledge of genetic algorithm is not limited to any specific branch. It is applicable across almost all the disciplines. For example, control, as I said, gas pipeline, pole balancing. Pole balancing is a very difficult problem as far as the control people are concerned. Just imagine one rod you are trying to balance on your hand, how difficult it is. So missile evasion, pursuit, design semiconductor layout. Semiconductor layout is a very, very tricky business. For example, integrated circuits, they have millions of transistors and there are different layers and there are different conditions that the joining lines should not cross each other, right? So you will agree that these problems, I'll just now read the names. Domain is control. You can read the application types, design, scheduling, manufacturing, etc. You may have some 50 machines. You have got now, say, let us say 20 jobs. So how to utilize all the machines in an efficient manner. No machine should be idle or no machine should be sort of overused. Robotics, machine learning. Please note that genetic algorithm is a part of artificial intelligence, right? So genetic algorithm is used for machine learning also. Now, okay. After this, I will now start talking some language connected with genetic algorithm. Now, chromosome. I would expect you to tell me what are you seeing on this screen. I'll read it one line. MH03AK5643. Next line is PP01BL3698. What are these actually? I want answers, at least from somebody.
Vehicle number.
Vehicle numbers.
These are the numbers, sir, of vehicle numbers.
Yes, absolutely right. Now, this is just an example of a chromosome, right? Say, for example, MH. MH stands for Maharashtra, right? Now, let us say 03. In Maharashtra, there are RTO offices. So this it means that, in Maharashtra, there is some particular office, RTO office, which is number 3. This particular number plate belongs to, pertains to a vehicle which has been registered with this office. Now, in this office, there are many vehicles. They will issue some series number, right? So they have issued this AK series number. Now, in that series number, this is the vehicle number, right? So a person from RTO office, if he sees this number plate, he will immediately able to say that, okay, this vehicle belongs to such and such RTO office, and they have there is a series of AK, and this is the number of that vehicle. Okay, so this is the example of a chromosome. Now I am saying example of a chromosome. What does it mean? This chromosome, I am just saying this is a number plate. Actually, they don't say that it is a chromosome, but as far as genetic algorithm is concerned, I am looking at it as a chromosome. Now, your duty, in case you want to write genetic algorithm, you will have to write the chromosome the way you would like. Okay. For example, instead of MH, they could have given some state number also. That possibility cannot be denied. But in their wisdom, they thought that it will be better to retain MH, right? So how to write a chromosome is the decision of the person who is writing genetic algorithms. So strictly speaking, genetic algorithm allows you to write the chromosome the way you would like, because you are the only person who is going to use it as far as your algorithm is concerned, right? Now, after saying this, I would now tell you that as far as this simple genetic algorithm is concerned, you do not have choice but to write it in binary mode. All of you understand binary 01, 01, 01. Okay. Now, let us say 2 digits. If I write in 01 in binary, the meaning is 1 in our day-to-day life. If I write 10 in binary terminology, the meaning is day-to-day life is 2. If I write 11 in binary language, in day-to-day language, it is 3. Am I right? I want your feedback.
Yes, sir. Yeah.
Okay.
Yes, sir.
So,
Yes, sir.
yeah. Did anyone talk? Okay. So all of you understand binary. So you will have to write, for example, image. You may give some number, maybe say 15 number, let us say. Then instead of image, you write 15 in binary language. Okay. You assign some, for example, here they have assigned 2 places in this chromosome for M and H. So in case you are to write it in binary, you will have to decide the how many places you will require for that. Here they require 2, you may require 5, 6, 7, because they will have to find out what is the maximum value you want to sort of get, and depending on that, you can have the length of the this part of the this is a parameter of a chromosome. You will have to reserve those many places for that information. Similarly, 03, it is written here in day-to-day language. Instead of 03, you will have to write it in as a 11, right? In binary language. Similarly, here this series, maybe this may be 75 or whatever it is, you will have to write it in binary language. So even now 5643 is in our day-to-day language, you will have to write it in binary code. So I'll just ask you one question. Are you able to visualize how to write this in binary language? I'll just say you will have to reserve some spaces for this image information. You will have to reserve some places for 03 information. You will have to reserve some places for AK. Similarly, 5643 also you will have to reserve these spaces. And you will have to write down the information in binary code. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So, in short, I'll tell you one thing. Now you are able to write down various parameters which are involved in, let us say, optimization, or I'll for taking sort of parameters, I will take some examples. Let us say that we want to design a car, right? So for car, you require how many passengers, whether it should be petrol or diesel. This will be one parameter. What should be the horsepower? That is another parameter. How many passengers it can carry? That will be another parameter. The fuel efficiency will be another parameter, right? So whatever parameters are required, you first imagine how many parameters you will have to deal with for designing a car. So you reserve those many places for those parameters and try to make your chromosome, right? So now you will ask me how to write a chromosome when you know nothing about it, right? So I'll try to answer it. So I'll now assume that you have some idea of chromosome. Chromosome is a string which has various parameters written in a binary language. Now, please remember, I am now talking about simple. The word simple is important. Simple genetic algorithm. I am not talking about genetic algorithm, because genetic algorithm allows you to have your chromosome the way you would like to code. Of course, when you do this, you will have the pros and cons of writing in that particular terminology. For a novice, it is now generally accepted that binary way of writing chromosome is the best way. Okay, so henceforth I will restrict myself to simple genetic algorithm. I will assume that the chromosome is a binary in nature. You are able to understand what the various parameters which are there, because you are going to write it and you are going to decode it, right? The person whosoever has designed this number plate nomenclature, they are able to decode image for Maharashtra, PP, for Punjab, West Bengal, etc., etc. These are RT offices. These are individual series of RT offices, and then these are the sort of number in that series. Okay, so you are able to write down the binary chromosome. Now, let me address you. Okay, I'll kindly do one thing. Just remember this discussion, because what I'll do, I'll touch upon some points and refer to them as and when required. Okay, so the chromosome concept is now understood by you. That I will assume. Can I say so?
Yes, sir.
Okay, fine, nice. Now, remember the joke about the philosopher and the actress, right? Now, what happens in nature? Now, this is string 1. You can see that there is same pattern all throughout. This is string 2, same pattern all throughout. And in nature, there is a crossover. Now we'll talk about the Darwin. Okay, so as far as the evolution is concerned, it has happened because of certain features of genetics. Now, genetic algorithm tries to imitate what is happening in nature. Okay, what is happening in genetics. So in genetics, there are various parameters. Not all parameters are implemented in simple genetic algorithm. In simple genetic algorithm, the crossover is implemented, mutation is implemented. Okay, so I'll now talk about the crossover. So the concept of crossover is, if this is a string 1 and this is the string 2, after the crossing over, you can see here this part is string 1, but this second part is from string 2. For this candidate, after crossover, this happens. Okay, so this part is belonging to string 1 and this part is belonging to string 2. Okay, so this is a concept of crossover. I'll emphasize this point again. This is called single point crossover. So let us assume that the crossover takes place here. So this one parent has got all the value 0. This is just for a demonstration, so that it becomes easy to understand the concept of crossover. Another parent has got only 1, 1, 1, 1, 1, 1. So there is a possibility that if the crossover takes place here, one child will have 0, 0, 0 from one parent and 1, 1, 1, 1, 1 from another parent. Another child can have 1, 1, 1, 1 from the second parent and 0, 0, 0 from the first parent. Is this clear? What is the concept of crossover? Okay. Now, in nature, crossover takes place not exactly in the way it has been depicted here. But in simple genetic algorithm, this simple understanding is implemented. If you want to write a complicated genetic algorithm for a very complicated problem, multi-point crossover is also possible. But multi-point crossover is strictly really not recommended for simple genetic algorithm. I'm just showing you just for the information. Kindly have a look at these two diagrams, and you will see that this one part is common to both the children, but these two parts are interchanged, and these two parts are see, instead of just look at the slide and kindly tell me after 1 minute or so whether the multi-point crossover concept is clear. I'll just wait. Have a look at the diagrams. I'll wait for your answer. Yeah. Can I assume that multi-point crossover is clear?
Yes, sir.
Yes, sir.
Okay, nice. Thank you. But I would emphasize multi-point crossover is generally not resorted to in simple genetic algorithm. The idea of myself talking about simple genetic algorithm is to keep things simple in the beginning. As you become expert, you can sort of indulge into a lot of difficult situation, complications, etc. Okay. Now, let us talk about crossover probability in nature. Many times you find that children, a child may be looking quite a lot like one of the parents, or sometimes you will find that the child will inherit some property from one parent and some property from another parent, right? So in nature, we observe that sort of written here, the crossover probability is generally from 0.6 to 0.9, right, on a scale of 1. Now, you will question what is the sanctity of 0.6 or what is the sanctity of 0.9? Can it not be 0.92? Can it not be 0.59? Now, please note, these are all fuzzy decisions. Okay, nobody can take, nobody can state with firm mathematical figure that in nature the probability of crossover is this much. You will agree with me. So, in general, we say that the crossover probability is 0.6 to 0.9, right? So it means that sometimes there may not be crossover. So what it means that the 1 minute, the children will, instead of like this, they will be copy of the parents. Okay, if there is no crossover. If there is a crossover, then these two children are possible. If there is no crossover, then they will be copy of the parents. Okay. See, here I have shown that this is some 1010 are arbitrary numbers because see, I have named philosopher, his intelligence. I have given 1 here. Beauty 0. 0 is not possible, but you know, we have to simplify the things. So actress has got, she has definitely some intelligence, but you know, for the sake of discussion, let us assume 0 intelligence, and beauty is 1. So now you see here, child 1 will inherit the intelligence from philosopher and beauty of the actress. So this is what was expressed by the actress. Now let us say that the child 2 has intelligence of the actress. Now, please note, don't get worried about zero intelligence and one complete beauty. These are arbitrary things. We have to approximate something. So, or we have to dramatize something. So, child 2 will have zero intelligence and zero beauty if there is a crossover, right, at some place. Now, child 3 will have, means there is no crossover. So, child 3 can be a copy of the philosopher, child 4 can be a copy of the actress. Okay. So, I'll just take a small, I'll ask questions. So, if there is a crossover, then the two possibilities are listed here. And if there is no crossover, the possibilities are listed here. Child 3, child 4 are no crossover, child 1, child 2 are crossover. Okay. So, the possibility of crossover decides what can happen. Now, I'll just sort of divert here and talk about who decides what will be the crossover. Okay, I did not have the sort of slide here, but okay. Can I tell you the story from Mahabharata? Yeah. Hello. I'm not showing it.
Yes, sir.
But I'll tell you the
Yes, sir.
story of Mahabharata. Okay. In Mahabharata, you know the character Shakuni, right? He plays in what is called in Sanskrit Dyut, right? And say gambling game, and there is a dice. You understand dice, no? So he plays that dice, and the reading is always to his favor or his party's favor. Okay. So was that dice real dice? That dice had a magical property, right?
Yes, yes, sir. Biased one.
Property was it was doctored. I'll put it that way. Okay. Now another example I'll give you is movie Sholay. I do not know whether do you know Sholay movie. It was a very famous movie sometime back. So there was a character played by Amitabh Bachchan. He had whenever there is a sort of dispute with his friend, he will toss that coin, and always Amitabh Bachchan will win. The reason was very simple. It was disclosed at the end of the movie that it had all one on one side, another side also one. So no matter how he tosses, he always wins. Okay. So I hope I made my point clear that dice can play havoc, right? Havoc can be in both ways, positive, negative, but we expect the dice to be dice, is it not? So, as far as the success of the genetic algorithm is concerned, the concept of dice or concept of randomness is extremely important. Unfortunately, I did not make a slide on that. So I'm just trying to explain it orally. Now, when I say that the possibility is from 0.6 to 0.9, so what I will do, I'll generate a random number, right? And that random number will tell me, say, of course, I will have to design that random number. So just for your information, the random number generator given in the book by Goldberg is widely used. Okay? I'll repeat my sentence. The random number generator code given in the book by Goldberg is widely used, and I would recommend that you should use that. The reason is that sometimes in say C languages, there are some random number generators are available, but they are really not that random. right? What we require, the random number should be really random and should not be just selected from few pre-decided numbers. Am I clear on this? Because this is the point which needs to be emphasized. I'll repeat my sentence. The random number is at the very core of the success of the genetic algorithm. If your code is not able to generate random number in really random manner, the answers you will get using genetic algorithm will not be the best answers. Is this sentence clear to you? I'll wait.
Yes, sir.
Okay, fine. Please note that I have
Yes, sir.
limitations because, yeah. Anybody said something? Okay. Now, let me talk about mutation. This is another concept from genetics which has been imported into genetic algorithms. Now, assume that there is a bear from Africa. Can you tell me the color of the African bear?
Black, sir.
Yes. And there are bears in Antarctica. What would be the color?
White.
Yes. Okay. Now, assume that some bears from Africa are put in Antarctica in where the original Antarctica bears are not around. Let us assume, hypothetical situation. Now, what will happen after maybe 10,000 years? Let us try to imagine. I am trying to give an example which will convince you the power of mutation. See, it is possible that due to mutation, things will change. Now, I will tell you one thing. There are parents, both the parents have black eyes, but one of the offsprings can have blue eyes. This happens in nature, we observe it. Now, both the parents may be having ordinary height, but one of the offsprings may have height higher than them. Or both the parents may be tall, but their offspring may not be as tall as them. So you see that in nature, one of the properties is absent in both the parents. Yeah. So, but it happens very rarely. Okay. So coming back to bears, it can happen that after some generation, some white hair would appear as a result of mutation in the bear population. After some years, because whiter the hair, the survivability will be better, right? After a few generations, you will see that there are many white hairs in that generation. So as I said, after 10,000 years, maybe 20,000 years, I am not expert on that, maybe the ancestors which are from Africa, their offsprings will have white hair. This is possible because of mutation. Now, am I making clear the power of mutation? It happens rarely. Now, generally, now this is, see, nobody can quantify these numbers 0.001 to 0.002. See, there is no way by which you can prove that these are correct, but these are approximately correct. And this is the robustness of the algorithm. Suppose you don't agree that it cannot be 0.001. You say that it can be 009. No, sorry, no, sorry. 0009. All right. So, but we observe that in nature, generally the crossover takes place with a probability of 0.6 to 0.9, and the mutation is rather rare, but has the probability of 0.001 to 0.002. Okay, I'll just wait here, and if there are any questions or doubts, I will take them right now before moving further.
Sir, how would you comprehend the mutation part in coding?
Okay, that I will come. That I will come. Yeah, that I will come. Good. For that, what I talked about the randomness, random number generator, you have to have that algorithm with you, which you say, basically what it means that, hello, random number generator, give me the probability of mutation, right? So it will tell you, okay, this is the thing. Then, depending on that answer, you will mutate that. I'll come to that. But before sort of making it clear, you should know the what exactly is expected from random number generator. For example, I have two strings which I can call as parent strings. Then I would like to create new generation by the process of crossover and mutation. So I will ask the random number generator, tell me the possibility of crossover in this for this situation. It will generate it randomly. It will say 0.7. Okay. Then it will also means with that, once it is decided, then I will ask another number at which place I should cross over, right? So I'll come back to it. I got your point. Other than that, any other question? Okay.
So actually, what is it meant by local maxima?
Oh, your local maxima. Okay, I'll go back. Okay. See, you see, I am just taking nature's example. These are the two hills. Can you see my pointer here? The person who asked this question.
Yes, I can say.
Okay, so there may be some small low point here, right? That can be local minima. See, as I said, I will not make a distinction between minima and maxima. You are asking me local maxima. I'll now talk local of negative maxima. Okay. So this point seems to be lower actually, but if you see here, there will be definitely a minimum point which will be better than this point. Or if I come to see here, you have got a minimum here, right? So you have got only one minimum, right? Now, this is also, that is called unimodal. Now, here you can see one minimum here, maybe one minimum here, one minimum here, right? So this is multimodal. And here, now for example, there will be some minimum here. Can you see this? One minimum. So this is, as far as this region is concerned, this is the local minimum. There are so many local minimums, right? So what we are interested in, global minimum. In this case, there are 1, 2, 3, 4 global minimums are there. Okay. So the whole idea is you should not get trapped into local minimum. Please be aware of this possibility that genetic algorithms can get trapped into local minimum. You should always make sure that you are not getting trapped. Okay, now this is the question you should be there with you all the time, only why. Okay, did I make the concept clear? local minimum?
Yes, sir.
Okay. So, see, these questions worry the generative algorithm users. So we are here. This is just a possibility. Now, this is example of a mutation, right? So I think somebody asked me how to sort of do this. This is a hypothetical example. Before mutation, all the points were 1, 1, 1, 1, 1, right? After mutation, you see that this point has changed here. Now, how to create a string after mutation? I'll now explain. Now you are here, okay? And you want to decide what will be the situation after mutation. So what you should do, you are here, you should say, hello random number generator, tell me the possibility for mutation at this location. Random number generator will tell you, don't mutate, okay? So you retain 1 here, then come here. Again ask the random number generator, hello, tell me whether I should mutate or not. Please note you had tuned your random number generator to give the answer for mutation, means generally from 0.001 to 0.002. Okay, that you have tuned that. So it will really do it in a random manner, not like a Shakuni of Mahabharata or like Amitabh Bachchan of Sholay movie. It will really do the duty of telling you the randomness possibility. It will tell you here, because you know that the mutation doesn't take place that often. It happens once in a blue moon, or say once in a 1,000. So it will tell you, hello, no mutation. So you write after mutation 1 here. Come here. Ask the random number generator, should I mutate? It will say no. You come here. You ask the random number generator. It will say, okay, mutate. So you wrote here. Instead of 1, it is 0. If it would have been 0 here, you would have written 1. Again, ask the question here, should I do the mutation? It will say no. Should I do the mutation? It will say no. Should I do the mutation? It will say no. Should I do the mutation? It will show no. Suppose this string would have been 1,000 places. Maybe only 1 mutation would have happened. Okay. So, is the idea how to mutate is clear? I'll wait for your response. See, please note the operation of crossover and the operation of mutation is at the heart of genetic algorithm. So, is the idea clear? I'm waiting for your response.
Yes, sir.
Yeah. So, as I said, crossover, if there is no crossover, there will be 2 children. If there is a crossover, there will be 2 children. So, so this is an extreme example where 4 possibilities are there, right? Okay. So, should I move over?
Sir, there's one more question. In case of crossover, there's a simple crossover. If taken 2 parents, is it possible to have multiple as in parents to generate
No.
more random?
No. Okay. You asked me a good question. So this is, see what happens, certain things I would have explained afterwards, but I'll explain it right now. See, your question is sort of well taken. Okay, I'll just explain. Simple genetic algorithm tries to imitate, please note the word imitate, the real world in a simplistic manner. Okay. Now, what exactly is the simplistic manner? I'll tell you, when I was in school, because we have to remember the population of India. Whosoever is going to school, they remember the population of India. Am I right? And every standard. So I remember my answer when I was in 4th standard. The population of India was 35 crores. Today, it is, I think, 1.3 billions. Okay, means 1300 crores, around that. So in real life, the population of India has changed, right? So in genetic algorithm, there is a concept of generation. I'll talk about it, but since you asked me this question, I'll explain it. See, genetic algorithms make one simple assumption that the population of any generation remains constant. Okay, and the two parents can have two children, and in real life we see grandfather, father, child. So three generations, sometimes 4 generations, sometimes 5 generations may exist simultaneously. In simple genetic algorithm, the concept of generation is there, but in a very simplistic manner. There is one generation that gives rise to next generation, and next generation is created by the process of crossover and mutation, correct? And of course, and also considering the, I have yet to come to that point, fitness. In other words, you at this point of time, you just remember things that in simple genetic algorithms, some very simple assumptions are made, which are not really realistic. But even though they are not that realistic, we get correct, more or less correct answer. So let us keep it simple. So to answer your question, in the simple genetic algorithm, two parents, if there is a crossover, they give rise to two children. If there is no crossover, they are giving, that means their children will be assumed to be similar to them, and they will be included in the next generation. And very drastic assumption in genetic algorithms is at any point of time, only one generation exists. Now, I'll just wait for your response. Did I clear myself to your question? I'll answer your question. Two parents can give only two children. If there is no crossover, their children will be just like their parents. If there is a crossover, the new children will be included in the next generation. I'll just wait here for any questions.
Yes, I sort of got your answer. It kind of replaces the original parent.
So population, see, there is only one generation. That generation gives rise to next generation. When the next generation comes into picture, own generation vanishes. Okay, and the number of the candidates in that particular generation, the so-called population of that generation, never grows. Okay, but that doesn't mean that you can write a genetic algorithm. You can write your own specialized genetic algorithm where the generation can grow. Okay, see, as I said, I'm restricting myself only to simple genetic algorithm. Okay, now let me move on. Now, I would like to talk about the concept of fitness. Now, yes, I have written here, user has to decide about fitness about a case in hand. Fitness can be a dynamic concept. Now, let us talk about how do we give entry to IITs, to those who pass 12th standard, right? So there is, first of all, there is a preliminary examiner or stage 1 exam, right? Where many students appear, they are evaluated, and from that advanced level test is taken, and from that to sort of they are ranked, selected numbers are ranked, and then given admission. So every time the fitness is criterion is different. It is different at stage 1, it is different at stage 2. Now suppose you want to employ somebody, then you will say that he should be, let us say that you want a clerk, he should be graduate in any discipline, right? And then you shortlist them. Then after shortlisting, you will interview them and then decide, okay? So basically what I would like to tell you that fitness, the concept of fitness is a dynamic concept, right? So at the sort of in the beginning of your genetic algorithm, when you create the first generation, right? Your fitness criterion can be different. You can tune your fitness criterion as you go from generation to generation, right? So the fitness concept is a dynamic concept, and the success of your genetic algorithm depends on your ability. Now, mark my words, your, Y-O-U-R, your ability to evaluate the sort of candidate, right? Candidate or that particular, in case you are designing something, you should be, there will be one chromosome. It will have various parameters. You should be able to interpret them and give them value. When it comes to, say, let us say, admission to engineering college, you say, what is your marks in physics, chemistry, maths, total, and etc., etc. So if you are not able to give them marks, your algorithm will not succeed. So this is completely your responsibility. What should be the fitness, right? Okay. Now, let me take example. Now, how much time we have got? 10 up to 11 o'clock, no? I'll just ask you one question. Is it boring? Because I'm making monologue actually. Just want something. It's the pace is okay?
Yes, sir.
Audience?
Yes, sir. It's perfectly okay.
Yeah. Now let us talk about fitness. See, you want to buy a car for a city, and you want to buy sort of use it only in cities, and let us say that only you are going to use it. So there will be many parameters, cost, then sort of what is mileage, what is maintenance, right? You would like to park it somewhere. Can you at many places? Because parking can be a problem. I remember we were visiting Air India building with students in a bus. Yeah. So yeah. So we went to Air India building from one gate. The watchman said, "You cannot park your bus here." He told that you come out from the out gate, again come inside, again go out, again come inside. What I would like to say that there can be constraint on parking. Okay, driver went and sort of had a roundup city. Now, so I'll come back to the question. You want to buy a car, and basically your decision will be you will have to give some fitness value to some. You will have some 4 or 5 models, let us say, right? So if you are going to have car for city or personal use, what matters most is the cost, then your sort of mileage, so many factors. So you will have to give fitness on various parameters and come out with So one single value. Now you have got 4 options. Let us say for one option, you get fitness of 0.9, another 0.85, another 0.89, or another 0.79. Finally, you will choose whichever is fit from your point of view. Did I make clear what is the concept of fitness? Fitness, it was consideration of various parameters and giving them marks and totaling them. I'll wait here for your answer. See, am I clear on the concept of fitness? See, I'm talking about day-to-day language, no mathematics. I gave you the example of you are a city dweller, you want to have a car for daily use in city, almost only single passenger, sometimes only 4. And you would like to, there are 4 models are available for you. Definitely you will not consider Land Rover unless until you are a president, right? You will choose economical models and you will arrive at the some notional fitness value and you will say, okay, this is the car I would like to purchase. Is it clear? Yeah, waiting for your answer.
Yes.
Yeah. See, now just to give another thing, suppose a villager wants to purchase a vehicle, right? And he is in a village surroundings. So the cars like Maruti Suzuki, etc., will have no use there because the roads are dusty, bumpy. So probably he may go for Scorpio, Mahindra car Scorpio, correct? So from his point of view, fitness for his situation means he will have to purchase same Mahindra type Scorpio vehicle or some other vehicle of that type, correct? So what I like to say, depending on the problem you are facing, situation you are there, the fitness value has to be tuned for that particular problem. And this has to be done only by you. Nobody else can do this. And if you make a mistake here, you will get wrong results. Okay. So let me move on to the next point and then I will just wait. Penalty function approach in fitness. Now, what exactly is the penalty function approach? Let me give you an example. You want to buy, let us say, a music system, and you have a budget of say 2,000. Okay, small personal music system portable. You have budget of 2,000. You go to a shop. You like what is there in that shop. You are satisfied on all aspects which you had in your mind. But the shopkeeper says, hello, the cost of this portable audio system is 2001. Your idea was to have a music system which should cost you 2,000 rupees. So in real life, now because this is, you say, okay, many times we have the budget restrictions. Am I right? I can buy this. Suppose you have got in your pocket some particular amount. You say, okay, I can purchase somewhere around this thing. So suppose that particular music system which you like, cost is 2001, right? So would you reject it completely?
No, sir.
No. See, now here, this has to be factored into fitness. Because many times there are constraints. If suppose some constraint is there and your candidate is not satisfying that, it poses a penalty, right? Now that penalty should be appropriate. Now, who will decide this? You are going to decide. Now, I'll suppose you are a finance minister, right? You want people to obey the laws as far as the income tax is concerned. Now, suppose somebody is not paying the income tax, and as a finance minister, you are empowered to give any sort of punishment to that person. So, would you recommend, as a finance minister, death punishment for that person? I want quick answer.
No, sir.
No. Okay. You are a finance minister and you have to decide the penalty. If somebody does not pay the penalty, he should be fined. Agreed. And the fine is 1 naya paisa. You understand 1 naya paisa? 1/100th of a rupee. Right? So if anybody who does not pay income tax, he will be penalized by giving a penalty, sort of a punishment of paying 1 naya paisa. What will happen? I'll give the answer. Nobody will pay income tax. I will say, okay, you take the 1 naya paisa and I am free. So is the penalty right in both the cases? One is giving death penalty, another imposing a fine of 1 naya paisa. Both are not correct. Am I right?
Yes, sir.
Yes, sir.
Okay. Now, this is a very, very difficult question. What should be the penalty? And you will see that every finance minister changes the penalty, right? So now you are using simple genetic algorithm and it is your duty to impose penalty. Now it is left to your judgment. Now please note this word. It is left to your judgment how much penalty you should impose, right? To the fitness, because fitness is depending on many parameters. You have evaluated them on parameters, given them some marks. Now there are some other parameters which are restrictive in nature, in the sense it should not exceed this, it should not, if it is a structure, it should not have this much displacement. Like that, there are many restricting situations, and your candidate is not obeying those restrictions. Then you say, okay, you got this many marks. But I'll deduct some marks from you because you are not satisfying this condition, right? So your penalty function approach in fitness has to figure in. So when you evaluate somebody, you also penalize in case the particular candidate is not satisfying some restrictions. Okay, so I'll just get your answers. Is the idea of fitness clear to you?
Yes, sir.
Okay. Now you are ready to for okay. See, I talked about the roulette wheel. This is a sort of example of how dice in real life. Okay. Now I'll. I think how much time we have? Got 3 minutes. Is it? Okay. I can finish within.
I mean, it's fine. We started a little late. You can probably extend 5-10 minutes.
Okay.
It's fine.
Okay. Now I'll see, this is the real life random number generator. Now, okay, let's see. I'll move to this slide first and then talk about it. Now, you see here in this 30 members are the population size is 30 in the generation 0. I taken from Goldberg book, so you can refer it. See, I mean, this is the initial generation. Now, somebody asked me sort of how to create the generation. So the generation, actually there are many parameters hidden inside which are known to the programmer only. Maybe first 3 places maybe for some particular parameter, next 5 places maybe for some other parameters. This is sort of known to the person who is coding it. Now, this entire generation is generated randomly, in the sense, okay, the first bit, you ask the random number generator, should it be 0 or 1? The probability here for this initial generation will be, it can be either 1 or it can be 0, 1 or 0, 1 or 0, 1 or 0. Correct? There is no other, the probability is 0.5. So for generating this, you ask random number generator, should I put 1 here or 0? It will say put 1. Should I put 1 here or 0? Probability is still 0.5. Huh? It will say 1. 1. Next answer will be 0, 0, 0. Next answer will be 1, 1. These are randomly given. So this entire population, these are sort of members of the population. This is a member of the generation 0, and there are 30 members like this. So this entire thing is generated randomly. Did I make clear how it is generated?
Yes, sir.
Generation 0. Okay. Now, the generation is given fitness. See, fitness is given by you only. How to give the fitness is your prerogative. Nobody can interfere that. So they are given fitness here. Now you will see here there are some candidates, they have got 0 fitness. There are some candidates, they have got 0.1657. See, I don't know whether it is readable or not, but you take it from me that the fitness varies from 0 to something. Okay. So now from this generation, we need to generate next generation. Okay. See, right now our problem is from one generation, that is here in front of you, that there is 0 generation number 0. It has to give rise to generation number next generation. Now, how to do that? So you have given them fitness values. Okay. So there are 30 candidates here. Now in this is, since the diagram should not become complicated, there are only 5 individuals are shown here, but you can imagine there are 30 individuals. What will be the distribution? Now here you see here, see fitness number is randomly. It is 1 to 5. His scale is 1 to 5 seems to be. Okay. So individual 1 is having fitness 1, individual 2 fitness 3, like that. So what he will do, he will total the fitness of all the candidates and say, let us have individual 1 has representation, this total fitness, 1 divided, this fitness 1 divided by total fitness will be the place reserved on this wheel for the individual 1. For the individual 2, this is this place reserved, this is the space given. So number 5 is the fittest. So he has been given this much of space. Okay. So on this roulette wheel, in this situation, there are 5 individuals. So the space given to them is proportionate to their fitnesses. Is this concept clear?
Yes, sir.
Is it clear? The space allocated here to various individuals is proportional to their fitnesses, individual fitnesses. Is it clear?
Yes, sir.
Okay. Now you will agree, if this wheel is rotated, actually this is like this. Who will win quite often? Quite often. Say, there is a chance that 5 will win
Number 5.
quite often. In case you feel that it should win only 33% times, but it need not be. Okay, this is the randomness. Okay, now 1 is here 7%, right? So the possibility that you would expect is rather less. But again, as I said, the randomness is at the heart of the sort of genetic algorithm. You resort to roulette wheel type. You rotate this. It may happen. The 5 may win 40% of time. 1 may win 8% of time. 13 be differently. Okay. So what we can say that the roulette wheel is biased toward candidates who are fitter. I'll repeat my sentence. The roulette wheel is biased. Bias means has a tendency towards making the candidates who have better fitness, their chances of winning are better. Okay. Is it clear? I want some feedback. I am not getting any answer because I would like this concept to be clear. I'll repeat my thing. Depending on the fitness of individual candidate, they are given space here on the roulette wheel. And when the wheel is turned, the chances are that these candidates will be winning not exactly to their proportion, but randomly somewhere near. Okay?
Yes, I guess.
So let us assume that here the possibility would have been 0, 0, 1. He did not give that, but the possibility would have been 0, 0, 1 fitness. So it means that that candidate has, but still that candidate had chance. I'll just give you one real life example. I know one person who is what is called popularly as a, it's not a very nice word, but mad person, right? You understand what we call in day-to-day language, somebody is mad, we say, you understand what that. But that particular individual had one very unique capability. You ask him spelling of, say, any word, he will tell you correctly, but in a reverse order. The table, you will first say E, L, A, B, T, or I'm sort of not able to recollect. See, table, you read it in the reverse manner and tell the spelling. That is correct, is it not? So he had that extraordinary capability of telling the sort of spelling in the reverse order. So don't you think that this is a very important gene he might have? So if such a person is not given chance, that gene will lapse and that sort of quality will be lost forever. Maybe it can get restored by mutation, whatever we don't know. But the roulette wheel concept is that though it is biased towards fitter candidates, it does not rule out winning of a very, very weak candidate. Okay. So the roulette wheel is used for sort of deciding either that particular candidate is winning or not. Okay. Now, you consider this candidate. Its fitness is here, and you know that it has been given place in the fortune wheel or that roulette wheel. All others are also given here. Okay. So now you have to generate the next generation. So you decide from all these candidates who will win. Maybe this candidate may win. Okay, so this is taken for parent 1. Now you require another parent. You again rotate this wheel. You get, let us say that you get this candidate as parent 2. Okay, now these 2 parents are selected. Then you ask the random number generator, what is the possibility of crossover? It will tell you. So, and you will ask another question, at which place I should cross over? That also you will be given by the random number generator. Then you make the necessary crossover or no crossover and generate 2 candidates for the next generation. Okay, so right. So these 2 candidates are generated for the next generation. Similarly, you again choose other 2 parents. They will give rise to 2 children. So go on doing this thing till the next generation is filled up. As I said, the population of any generation does not change, it remains constant. Once you have generated from this, selecting the parents, and is the chances of fitter candidates getting selected is pretty good. And their children, because of the process of crossover and mutation, their children are likely to be brighter than them or not as good as the parents. But the fortune wheel selection will make sure that those who are not fit will get dropped out next time also. So, I'm now almost coming to the explanation. Is the process of generating next generation clear?
Yes, sir.
Okay. Now, it's another sort of slide can be generation 1, generation 2, generation 3, generation 4, generation 5, generation 6, right? So where to stop? That has to be decided by the fitness. The moment the fitness is to your liking, you can stop. So I am just now giving the building blocks of the simple genetic algorithm. Create an initial generation randomly. As I said, you don't break your head. You say, go on asking the random number generator, what should be the digit here? 0, 1, 0, 1 with the probability of 0.5. Create initial. Then assign fitness to the members of the generation. Now, create new generation. As I said, for creating new generation, you have to take care, make use of Hawking wheel, that Rowlett wheel, crossover, rotation, create new generation, assign fitness to the new generation. Now, you will see that when you get nearer the answers, no, the fitness values will be very, very close to each other, right? Say they will differ very minutely, means the entire generation will be very, very fit. And from that very fit, you select the best one. It is something like this. You have got 8 persons participating in Olympics for the final, and you give gold medal to the first one. But it doesn't mean that the person who ran last in the final of Olympics was bad. He was a world standard athlete. Do you agree? So you will stop the generation once you are satisfied that all the candidates are very good. Then if you are satisfied with the results, means you select the best of the best, then stop, else go to create new generation, assign fitness. This cycle will go on. So in essence, actually, this is the last slide I will to talk. What should be the population of generation and how many generations should be there? Now, population of generation is decided by the memory of your computer, right? Suppose you want to have 1 million population of, in a generation, your computer will not be able to accommodate it. So your population of generation will be limited by the computer size you have and the computer memory you have. Then, how many generations should be there? Now, these are open questions. Now, I'll just give you, I'm just coming to end of my presentation. I'm talking to you. Let us say that you are predicting what will be the sort of weather tomorrow. Okay, you are a weather scientist and you want to predict correctly what will be the weather tomorrow, and you want to make it as accurate as possible. Now you have got a fantastic algorithm. It runs for 2 days and tells you what will be the weather for tomorrow. Is it acceptable? If your computer is taking 3 days to tell you what will be the weather tomorrow, what is the use of that algorithm? It is of no use, is it not? So, how many generations should be there has to be decided by you, because it depends on how much accuracy you want. If you want infinite accuracy, you will have to, your computer program will run for months together. But if you want sufficiently good accuracy,
Professor Chimpy, are you there? Have we lost you? Professor Chimpy? Okay, I think I can't see him. Ah, here he is. He seems to be okay. I mean, I don't see a network problem. Let me call him up. It shows the same kind of triangle that we saw earlier. It is showing that triangle. So maybe your data pack has expired or something. Okay. Okay. So maybe. Huh. Sure. 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 Okay. So I think. Yeah. Sure. So Professor Shimpi will join in a minute. He has almost finished. I think this is the last slide. He'll conclude. Let me take this opportunity to make one announcement, a reminder rather. Uh, Last workshop, quite a few of you started requesting for certificates. So as the part of this course, you will get a certificate. The criteria is, one, you should have minimum 80% attendance. Second, there will be an assessment at the end of the course. The last session will be an assessment session. It will be a quiz of 10-15 questions. And you are supposed to score minimum of 60% marks there. Unless you do that, AICT. So I'll upload the attendance, I'll upload the marks. And that quiz will be set up on Google Google Quiz, Google Forms, whatever you call it. And you need to score 60% of the marks. The questions that I have picked are coming from the instructors themselves. Okay, Professor Shimpi is here.
Yeah.
Okay, Professor Shimpi.
Yeah. Yeah. So I'd like to ask the last point I talked about, how many generations should be there and what should be the size of the population. Did everybody see that?
Yes, sir. Yeah, we saw that slide.
Yeah, you saw that slide. 1 minute. So actually, I have finished my presentation. So if there are any questions, I would like to see. This is the last slide which I showed. So this is the last slide. If there are questions, I would like to take them up. I'll just make one comment. I tried to introduce simple genetic algorithm, right? The concept involved in that. And if you read the book of Goldberg, you will be able to sort of digest many points there. Any questions at this point? I hope I am audible.
To me, you are.
Yeah. So any questions? Not getting any response.
Well, I mean, this is one of the few lectures which has relatively smaller content of mathematics. Otherwise, most of the other lectures will have quite a few equations here and there. So I'm really worried about the response. If the response is low for this lecture, then I don't know. I mean, participants, please, you need to respond. You need to participate. It's very embarrassing for us also to contact lecturers and conduct this if the response is not there.
Sir, I have one question, sir. Can you ask?
Yes.
So good morning, sir. I'm Dr. Aditya Bari from Indore. Sir, I just want to ask that in this advantages, you have told that this is a robust. So
Yes.
how this robust is the advantages means if this algorithm is taking more and more time, so that means how it is advantages that I just want to know, sir.
They're robust in the sense that suppose whatever problem you are solving, right? For example, the probability of crossover, instead of taking 0.6, you take 0.59, still it will get good answers, right? So See, can you ask me that question again? Because I would like to get a very pointed question. What exactly is your question? Can you pose that question?
Sir, actually, yes, yes. Sir, I just want to ask that in this advantages, you have said that robust is the advantages of this particular
Okay,
GA.
okay. See, robust, as I gave the example of joining. If you want to join using what I can say, Fevicol, the method is robust in the sense anybody, any child, adult, man, woman can join that, right? Now, but if you want to use welding, only welder can do that. So welding is not a robust process, whereas using Fevicol for joining is a robust process, and using welding for joining is a specialized process, right? Now, so in case, suppose I am making some small mistake in my deciding the probability of say mutation, still I will get okay answer, right? So see, if you read different books, they will recommend the probability of crossover can be above 0.9. Somebody will say above 0.8. So you will get confused by different recommendations. But if you apply any recommendation which is sound in nature, please note I am using very fuzzy word. Of course, you can't say that the mutation will happen 100% times. If that is the thing you genetic algorithm will go wrong. Okay. See, the possibility of mutation, even if you say 50%, is against the nature. So you are not imitating the nature. But if you say between this 0.1 or 0.2%, or 1 upon 1,000 or 2 upon 1,000, it's okay. So to this extent, we can this algorithm to be robust. In the sense, it does not require very specialized knowledge of what exactly is the possibility or mutation or the particular problem. Is it clear?
Yes, sir.
Hello.
Thank you, sir.
Yeah.
Yes,
Okay.
sir. Yes,
Any other
sir.
question?
It's clear, sir. Thank you very much, sir.
Yeah. So, any other question? I think you respond to kindly the question which posed by Professor Akshay, because probably I may be the sort of lecturer who is not using any mathematics at all. Is it okay or is it not good?
So there are two questions in chat. One of the questions is, sir, will there be any coding exercise for GA? I have replied that unfortunately none of the sessions, including yours and including future sessions in this workshop, have hands-on sessions. But they can ask you for references if they want.
Please note that we teach this course for a semester,
Yeah.
right? So we also give them individual projects, and these are the hands-on experience for students, but that can be practiced in a full course. I'll just give you an example of a particular assignment. Some student was having some eye problem, so he was recommended different medicines. So there were say 2-3 alternative medicines. He used the algorithm to get the best medicine for him, right? So these are the individual problems which we can solve. But as far as you are concerned, the algorithm is given at the end of the book of Goldberg. You can sort of run it and get your excellence. So as far as I am concerned, I try to give you insight into algorithm, what exactly it is, and how to go about it. And resource, as I said, Goldberg's book. Okay. Yeah. I think Professor Akshay, you decide when to terminate.
One question in the chat. What
Ah.
circumstances Cauchy mutation can be applied?
To be very frank, I have no idea what exactly is Cauchy mutation. In case the person has the idea what is Cauchy mutation, can you explain that?
This is Dr. Koteshwara Rao. Maybe Professor Gogulopati, who is also an expert on this, can explain. Professor Gogulopati, can you take a shot at it?
I don't know what Cauchy mutation is.
So Professor Koteshwar, Dr. Koteshwar, if you can maybe elaborate a little bit more on what is Cauchy mutation, because
Hello, sir. Good morning, sir. Sir, I am referring the two textbooks for genetic algorithms. One is the Rajashekaran, and second one is the Sivanandam textbook. So, in that textbook, regarding to the mutations, there will be a fixed point mutation, random point mutation, and Cauchy mutation. So, in the Cauchy mutation, what is happening is, whatever the gene that is having the lowest fitness value, it can be replaced with the next highest fitness value.
These are all the fine points.
So that's why also having some doubts about it. That's why I am, because from morning onwards I am listening the session. It is very impressive, sir, and very attentive also. That's why I am asking this question.
Good. So the lecture allows you to frame difficult questions. See, I'll tell you one thing. This whole thing came into existence in, say, let us say, became popular in 90s. So people are evaluating it. For I'll just not only this, I'll tell you there are parallel GAs. In fact, I did some innovation which did not succeed, but got good attention in the community. I tried to mix simulated annealing with genetic algorithm. It was not a success because both simulated annealing is a sort of renowned method, as genetic algorithm is renowned method. When I tried to combine them, it was not a success. So in short, actually many experiments are going on, and right now there is no final word as such what exactly is the best way of implementing genetic algorithm. The way I think Cauchy mutation may be recommended in some situations. There are, so in real life, there are some particular drugs are valid only for some particular situation. They may not be valid for general. We are now talking about general, simple genetic algorithm. So you are talking about some small situation there which I am not aware of, and but genetic algorithms are evolving from generation to generations now. Yeah.
Yes, sir. There is another small question, sir. This is the last question from my side. Sir, why many of the researchers are stating that genetic algorithm is outperforming the particle swarm of?
Actually, this is Professor Akshay. Can I answer him within say
yes,
2
yes,
minutes or so?
please take your time. Please take your
This
time.
is actually this is this cannot be answered. I'll tell you. Now, can you be specific in which situation genetic algorithms are performing?
Sir, suppose if I'm applying for generating the optimal test cases, when I'm applying the PSO and as well as the PA, so optimal test cases can be generated by the genetic algorithm when we are considering the 4 parameters like fitness value, test case count, and memory utilization, and time for execution.
Okay, answer to you is I am giving indirect answer. Okay, you have
Yes,
got a rifle and you have got what I can say machine gun.
Yes, sir.
Both can kill. Now suppose you are facing an enemy and in your command right now there are 2 weapons. One is a rifle and another is machine gun. Suppose the enemy has a far distance. Which weapon you will use? Rifle.
Yes, sir.
Because you can take time to aim and kill the enemy with sure shot thing. But suppose
Yes,
you are having 20 soldiers nearby you
Yes, sir.
And you are not going to use rifle. You are going to use machine gun. Are you going to aim it individually or just fire randomly?
Randomly.
Randomly. So when you have got a very difficult situation where you want answer as quickly as possible, use particles for optimization. When
Yes, sir.
you have got enough time at your disposal, there is no time pressure, then use genetic algorithm. This is my answer, indirect answer to your question. And when you are comparing both the methods, you should compare them when the computational time is same. Because you cannot say, I use particles form optimization, I got this answer. I use genetic algorithm for this answer. I am not knowing what sort of computational time you took, what sort of memory you use. When you want to compare, these have to be kept in mind. But the correct answer is, which I give you, when you will use rifle, when you will use machine gun. See, particles form optimization is to be used when you have got a huge problem before you, to be sort of get as approximate answer as possible in the quickest time. You are not going to get 100% correct answer, but you will get very good answer. I think I answered your question to the best of my ability.
Yes, sir. Yes, sir. Thank you,
May
sir.
I take a stab at the first question about the Cauchy mutation? Yeah? What do you-
Yeah, sure. Go ahead.
So actually, I was just looking at the Cauchy mutation. So the shapes are very similar to a Gaussian or normal, but the fundamental difference is the Cauchy mutation. It's a much more natural way of describing the distribution in several situations. That's why it is preferred from a theoretical point of view. From a numerical point of view or from other properties, it has some properties which, or it does not have some properties which Gaussian brings to the table. And it also has a few properties that the Gaussian does not have, like being theoretically easier to handle. Does it answer your question, or did you want something more specific?
Yes, sir. Yes, sir.
So both should do the job. In a numerical sense, if you have the problem, both should do the job. But the Cauchy mutation is much more natural in several situations because it's the tangent, the expression is the tangent of the Gaussian normal distribution in several situations. So wherever you want to set up a problem theoretically, and you want to take it further than what Gaussian gives you, Cauchy mutation is much better. But it cannot calculate mean because if you look at the plots, the integral from -infinity to infinity doesn't exist.
Yes, sir. Yes, sir.
Yes. Sorry, that's all I had to look up what Cauchy mutation was.
Okay, so I was speaking with muted on. So Dr. Koteshwar, I think, wants email addresses. So let me point out here that all the lecturers are public figures. I mean, in the sense, all are professors in some institutions, and you can go and
Actually,
look at their profile. I'll also, I mean, you can also ask instructor, for example, Professor
yeah,
Shikhi can.
yeah, this is my address. I given email address. Or can be communicated, to them.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir.
Okay.
So one question, sir.
Yeah.
Sir, have there been any cases where genetic algorithm has failed?
Has failed. See, failure or success depends on the person who is using it. If he is not able to decide the fitness properly, it is going to fail. If he is not able to find out what are the parameters involved, he is going to fail. He or she is going to fail. So failure is not the algorithm. Failure is the person who is using it incompetently. And
Okay.
one more thing, as I said, failure, if you want 100% correct answer, yes, it fails. But we don't use genetic algorithms when we fail to get the absolute correct answer using calculus or mathematics. When we are helpless, so for example, you are facing an optimization problem which using your mathematical tools you are not able to solve at all, then you will say to whosoever you want, hey God, hey Almighty, or hey whatever may be the ultimate thing you believe, please help me, please give me some way by which I can get some answers. Then you will have to use one of the nature-based algorithms, one of them is genetic algorithm. So it does not really fail. Or it will be a next wonder if somebody cites an example where the genetic algorithm fails. Till now, I have not come across any situation where it has failed at the hands of a competent person.
So let me point out, chip in here. I mean, lots of new BTech students nowadays want this neural networks on their CV. So they come that, can we do this with neural networks? Can we do that with neural network? And I remember watching a YouTube video of a famous scientist or some lecturer, and he says that you use neural networks or these statistics based methods only when you have given up on science. If your equations cannot predict a correct value, only then you go to these statistical based methods where you can get something out of it even if you don't know the physics behind it. So I guess if you don't know anything, any kind of indication, any kind of knowledge, any kind of idea that okay, I can go do better in this way is better than nothing, right? I guess that is what Professor Shimpi is trying to say here. So you must expect what should be expected and not something which is unrealistic. Have I put it correctly, Professor Gogulapati? I hope I have.
Yeah, I'll chip in with another thing which I have noticed as well. So, in classes I teach, people ask me a lot of questions about these meta heuristic methods. Genetic algorithms was the first one in many ways, and there are so many population based methods. Now, one of the you have to understand that the optimization community is split about what method is best. There are those who believe these derivative free methods are great. There are those who believe that derivative based methods are great. Am I audible?
Yes, you are.
Yeah. So these meta heuristic methods have become more and more prominent only with the advent of data driven methods, because dimensionality reduction can be achieved using data driven methods. If you want to track a system which has anything more than 100 degrees of freedom, genetic algorithms, PSO, all these things, you cannot handle it anymore. So they have severe limitations on how many variables they can handle. Whereas, and this is the argument of the community who favor the gradient based, is that gradient based can scale up because it's all defined using mathematically rigorous concepts. Even if you don't have some concepts at your disposal, like let's say continuity is not guaranteed or whatever, you can still define certain quantities. That's what projected gradients are, discontinuous gradients are. And you can use the mathematical rigor to drive the problem, and that's where scale up also comes in. So point one, genetic algorithms are extremely powerful if you know how to use them. Point two, they have a limitation in how many design variables they can handle. This is curse of dimensionality. It has nothing to do with genetic algorithm. Any population-based method is this, has this limitation. So I have seen cases where
మమ్మల్ని పిలిచి అడిగారు సీన్ ఎక్కడుంది శ్రీనివాస్ నువ్వు ఏం మాట్లాడుతున్నారా బాబు
so anyway, that was what I was saying. So
Uh, I see one user, I see a call-in user. I'm just curious, did you have any trouble calling in and attending? Call-in user 3, I think. No? Okay, so I guess he's muted, he won't speak. Okay, so one last reminder about the assessment, which I was trying to tell you earlier. You need 80% attendance and you need 60% marks in the assessment, and you need 80% attendance for all the lectures, right? So so if you don't have that, you will not get the certificate from AICT. So please make sure that you attend 80% and you ensure 60% marks. Generally, questions I ask from the instructors to give me a few questions, and I'll compile 10-15 questions in a Google form and send it across to you. You will have 10-15 minutes to fill it out. It will be MCQ, multiple choice question. You just have to click. It won't take more than 5 minutes. You will have 15 minutes in the last session, and then we'll also have a feedback discussion at that point. So please, in the last workshop, lots of people came up that I attended. I will, the attendance will be taken from the Cisco app itself. It creates some sort of file which tells me how many have attended for what duration. If your name is there, I'll mark you present. That's it. But you must attend. You must attend 80% to get that certificate, right? Okay, so with this, we will close. Next session will start at 5 p.m. in the evening. Well, I'll see all of you then. Okay, so
Sir, is it 5 p.m., sir?
yes, 17 hours, 5 p.m.
Okay, thank you.
So the next session is in the evening, 5 p.m. to 8 p.m. 2 sessions, 1.5 hours each. Okay. Okay then. See you guys in the evening.
Thank you, sir.
Thank you, sir.
Thank you, Professor Shiv.
Thank you, sir.
Thanks,
Thank
everybody.
you.
Thank you.
Akshay, you want me to hang around?
I was hoping that call-in user 3 would respond, but it seems he's not responding. So maybe
Okay.
we can log off. It seems
Okay.
people can call in and join. So okay then,
Yeah.
see you in the evening. Do you want to continue in the evening, or should I mean, should we do it like this, or?
Yeah, this is fine. So
Okay.
if you can log in, you log in, and I'll also be there so
Sure.
that we can share duties.
Sure. Okay.
Yeah. If you have something, then I'll take over. That's not a problem.
Well, not today. Not today. Okay.
Okay.
Okay then. See you. Bye.
Bye. Bye, Professor Shimpi.
Yeah, bye. Thanks.